Okay, this chart's about Newton number 3 and the gravitational force. If you think about the interaction between the moon and the earth, this is an example of the gravitational force. There is the force of the moon on the earth pointing from the earth to the moon, and there is a reaction force, the third law of pair, the force of the earth on the moon. Now, if the moon wasn't circling around the Earth executing what to a good approximation is UCM, the Earth would accelerate. The moon would accelerate towards the Earth, and the Earth would accelerate towards the moon, and there would be a planetary collision. But because of the uniform circular motion, the moon stays where it is in its radial position. But what's interesting, though, is the tidal bulge that comes up on the Earth because of the great amount of water that our planet has, and the result of that is that the water close to the moon gets pulled towards the moon, and the water furthest away from the moon it bulges out, and so you get a bulge inward and a bulge outward, and that was one of the indications to Newton that there was a Newton's third law. In other words, that the Earth exerted a force on the moon, but there was also a pair to that force, a reciprocal force of the moon on the Earth. So another example is a ball that is falling towards the Earth, and so the ball will accelerate towards the Earth because there is a force of the Earth on the ball, but reciprocally there is a force of the ball on the Earth. So the ball pulls just as hard upward on the Earth as the Earth pulls downward on the ball. And although the acceleration of the ball downwards is the little g that we talk about in class all the time, the acceleration of the Earth is effectively zero, because by Newton's second law, the acceleration of the Earth is the force of the ball on the Earth divided by the mass of the Earth, and therefore it's the ratio of the mass of the ball to the mass of the Earth times little g. And if you put the numbers in here, if it's a 1 kilogram mass for the ball, then in the numerator we have roughly 10, and in the denominator we have 6 times 10 to the 24 kgs. That's the mass of the Earth, and what one gets is from that is well, 1 over 6 is 0.16, and so that comes out to be, rounding it out, 2 times 10 to the minus 24th meters per second, effectively zero.